Hello, good morning, afternoon, evening, everyone, wherever you are. My name is Ivan Kastelan, and on the behalf of the organizing committee of the CBS and ZINC conferences, I welcome you to this session. This is the third session of the ZINC conference on automotive solutions. Just a few technical details before we start. Thank you for uploading your presentations on the ERAS portal. We are going to run the presentations directly from our computers, so you can just I will give you the screen the control, and then you can just click on the keyboard arrows or mouse to change the slides. And now I would like to give the floor to the session chair, Chi Peng Fan from the National Chung Hsing University in Taiwan.
Thank you. Okay, thank you. Thank you for Ivan's introduction. It is my pleasure that I could serve as the section chair for this section. The section title of this section is ZINC 3 Automotive Solutions. And I would like to introduce the title of the first paper. The title of the first paper is Evaluation of Ethernet Subsystem for Domain Controller in Autonomous Vehicles. This paper has 3 authors. The authors are from Serbia. And please start the presentation. Thank you. And the speaker is Dušan, please.
Hello, everyone. Session chair already introduced me. My name is Dušan. I'm one of the authors in this paper. Besides me, there are Marija, Antic, and Milan, Bjelica. And I'm really delighted to actually be here today to open the session and to contribute to the scientific development of such an area as the automotive industry. And I'm really sure that by now we are all aware of the amazing functionalities and features which are implemented and provided via new generation modern vehicles. So I will not directly talk about that, but I will try to present the communication subsystem more precisely to present the evaluation of Ethernet subsystem for domain controller in autonomous vehicles. Usage of the before mentioned amazing functionalities and features in modern vehicle actually increase the number of physical components in modern car, which basically means that entire system grows, and so does the communication problems within it grows too. The problems of connecting all that different parts and different entities in the system. And furthermore, the system components are grouped based on the functionalities they perform within an architecture called domain controller. And on this slide, we can actually see one general architecture of domain controller for driver assistance services and control services. We can see that there is an automotive microcontroller, basically a microcontroller with some special features and functionalities specialized for automotive industry. Some examples of it can be Infineon RX or Renesas RH devices or something like that. Then we have a general purpose microcontroller, and some typical example of it can be FPGA. Then we have some data processing devices to handle the data provided by different kinds of sensors. And what is important that we can see Automotive Ethernet as in a role actually of a communication backbone as it connects all those relevant parts together. And I would like to point out that we can actually see some additional communication technologies, for example, Canon FlexRay in here. And I just wanted to accent on with this that Automotive Ethernet will not completely replace all communication technologies. They all have important roles to play, so they must stay included in the system. Earlier, classic Ethernet actually does not have some, didn't have some suitable specifications in order to become a communication backbone. Too much pairs of wire, high noise and high bandwidth frequencies, then unnecessarily long cables, and bad resistance to extreme environmental conditions actually make the classic Ethernet unable to become a communication backbone. And those are obvious hardware feature requirements in automotive industry that we actually need to satisfy. Besides those hardware requirements, we have additional data flow requirements. For example, data must be properly transmitted through the entire system, and the ability of a system to learn MAC addresses of connected devices should be enabled too. Then 10 milliseconds end-to-end latency for communication between services which actually provides a comfortable driving should also be satisfied. Then requirement that 1/4 of millisecond to millisecond end-to-end latency for communication between driver assistance and control services should also be satisfied with the bandwidth from 20 megabits per second to 100 megabits per second. And of course, VLAN configuration and traffic prioritization should be included. Okay. For the Ethernet subsystem architecture, we actually choose a hybrid topology, actually, because we have 3 linear daisy chain connected Ethernet switches, and on each of them we have connected peripherals devices in structure, in actually star structure topology. So basically they're all making one hybrid architecture. It is a common situation that some of switch ports does not have a suitable media independent interface type, and in that scenario we need to actually use some of the physical transceivers as corresponding media converters. We covered that scenarios on 5 paths. All of them are depicted with a circle. So basically we can measure potential limitations of latency and bandwidth. And in order for components to be actually integrated in such manner, we also need to pay attention to properly configure the speed of ports, to configure the media independent interface type of all those ports. And we also need to pay attention to one more detail. If we want to provide the possibility to actually configure and manage our switches from the external CPU or microcontroller, we actually need to enable remote management unit option on those ports. Ports on all 3 Ethernet switches. And first step of the evaluation after we successfully integrate our system, first step will be to show that all physical criteria I mentioned before are practically met. And this is pretty much easily achieved by by using the network Ethernet switches, which are practically support the Automotive Ethernet standards. So basically, we will have single pair of wires. We will have our bandwidth frequencies reduced to 33 megahertz, which is practically halved from the classic Ethernet, and we will have operating mode in even extreme conditions. Okay, and regarding the evaluation of data flow requirements, I mentioned we need to test some basic functionalities, and in order to test them, the external PC will be needed. We connected our external PC on practically on all ports, one at a time, of course. And for each scenario, we sent 10,000 frames from PC to our microcontroller and vice versa, of course. And we actually examined frame counters, which will show to us if traffic is forward correctly. So basically, we can examine how much good octets are, how much good octets came to our port, then how much bad octets came to our port, and of course how much octets actually egress from our switch on that typical port. So basically, we can see how the entire forwarding actually passed smoothly and everything is fine. So this is the situation we were looking forward to. And of course, we additionally examined switches address tables to confirm that MAC addresses of all devices connecting to our system are actually present in those address tables. And end-to-end latency and bandwidth measurements were done in the manner that we actually measure 9 relevant paths. And I would just say that only 2 of them were practically critical and should be additional attention paid for those paths. And the scenarios are when we transmitting frames from 1 to 3rd or vice versa from 3rd to 1 switch with at least 1 media converters on those paths. And regarding the evaluation of VLAN configuration and traffic prioritization, the tests were performed practically very similar like it was the case with the basic functionalities, but in this scenarios we sent actually 20,000 of frames from external PC to microcontroller and vice versa, and half of them has the correct VLAN IDs, and half of them actually have the wrong ones. Basically, I just wanted to add that here we examined 2 additional counters to see if actually filtering policy went well, and in this manner we can conclude our paper. We show the overview of the requirements, we disclose the entire subsystem and the process of integration and testing. Thank you for your attention, and sorry if I
thank you. It's okay. Yeah. It's okay.
Okay.
It's just on time. Okay. Thank you.
Yeah, of course.
Thank you very much. Thank you.
Thank you.
So thank you very much for the speaker's excellent presentation. So any question from the audience? Any question from audience? Okay. If no question, because our section time is limited, so thank you the speaker again. Thank you. Okay, thank you very much.